Hallå. Jag kan inte skriva, jag är lite halvnöjd faktiskt. Hon är i varje fall online och hon har hört av sig här 1729 som vi säger. Och då är frågan om det här kommer att fungera. Jag vill gärna ha en respons där från henne. Men det är ju så att vi har ju inte varit helt goda vänner med våra elektronik.
Ja.
Okej. Då kör vi så får vi se var vi hamnar någonstans. Vi provar med video också. Hej! Hej!
I guess good evening, right?
Yes,
Morning for me.
I'm sure we are more happy to see you than you are to see us, but we are very happy to see you, and very nice that you were able to get up. I know that it is an ungodly time to actually start working. Hopefully you can go to bed again, I don't know. Very much welcome to our small public observatory, the Tycho Brahe Observatory. And we have just inaugurated this little space sculpture. And as you see, there are quite a lot of people here. Let's see if I can you see us?
Yes.
Hi. That's working. Fantastic, fantastic. So, now tell us, what happened? How did this new celestial body be discovered? How does it work? If you are a professional astronomer and discovering something like this, please tell us.
Well, it's a little bit like looking for a moving blob on the screen. So I was a graduate student at Caltech in Pasadena, and we were using the Samuel Ocean Telescope to look for objects beyond Pluto. And the idea was to sort of understand more about their orbit and potentially tell us about maybe an event like a passing star or other things that we had sort of inferred might be happening had happened in the outer solar system. But by having those orbits of these more distant objects, it's really like doing archaeology. And so their orbits are sort of like the fossils that can tell you about these past events that may have been wiped clean from the rest of the orbits of the solar system.
Meg, just a second. Since the connection is a little bit garbling, could you just take it a little bit slower just to make sure that it gets through?
I would probably turn the video off. I think that'll help.
No, it's okay. It's okay. It's, yeah. No problem. Just continue. So, could you tell again what was the telescope you were using at the time?
The Samuel Ocean Telescope.
So, how large is that?
It's 48 inch. So 1 point something meter.
Yes.
3?
So it's a wide field telescope, I can imagine.
Yes. And so we can see things about up to about Mars size out to about 300 AU. So roughly about 15 times what we can see from where Neptune is. So yeah.
So things about Mars size out to 300 astronomical units, that's what you're saying. As if I remember correctly, this particular object is currently at about 80 astronomical units distance from us.
Yes.
And it's getting closer, or do you know which kind of orbit it has?
It's near the closest approach to its regular perihelion.
That's why. That's why you found it, I can imagine.
Right. Well, it's the best chances for us to find it is when it's its brightest, right? And it just happened to be big. There really isn't any specific reason we found it. We were looking for other objects. We're trying to complete the census for what we know is out there. And we happened to find it. So although 2007 hour kind of big, that's just sort of luck.
But that's typical science, isn't it? To have luck. It's also called gut feeling and intuition and all these beautiful names which are perhaps somewhat typical characteristics of good scientists.
I don't think that. I think There's no gut feeling in this one. I think it's just that it happened to be there. The software found it. It did exactly what we expected to do. Something was there. What's tough about 2007 OR10 is that it's bright enough for us to find it, but it's very hard for us to use ground-based and space-based telescopes to study it. So before its discovery, other brighter Pluto-sized bodies have been found, and that people were able to follow up and study their surface composition, search for moons, and do a lot more sort of understanding of their surfaces. It's one of the reasons why we haven't given 2007 OR10 a name, is that for all the dwarf planets, they have a name that's very fitting based on what we know about it. Very much about 2007 OR10. So I've always held off naming it just yet because we've only started to learn more about it to give it a name that it deserves.
Has it been studied from space as well, or not?
A bit with the Hubble Space Telescope. So they found that it now has a moon, so that's why your lovely sculpture and setup has a moon with it.
Yes.
So that was just discovered, recently discovered last year. So we don't actually know how the moon orbits 2007 OR10. We just know that there is a moon. So people are following that up now with Hubble, or hopefully soon with Hubble Space Telescope. And the moon's so close that from the ground we wouldn't be able to see it. It would look like one object to us. So you really need to go above the atmosphere and the blur and effects from it to be able to pick out that.
It's in the order of 1 arcsecond or less, possibly.
Yes, much less than that, I believe.
But I understand we talked earlier this week that you are discussing a suitable name for it. To what extent can you influence that naming, and given that it's the Astronomical Union that actually decides on it?
Well, I have another year and a half, 2 years to officially submit a naming suggestion. So I don't get to name it. I get to suggest a name that the IAU, the International Astronomical Union, can consider and decide to bestow. So I believe I have another year. I have 10 years from when it has the object in a secure orbit to suggest a name. So we have a few more years for that.
But so we would be free to suggest to you a name, I can imagine.
I'm sure, but I also have 2 other key people that I've been trying to convince.
But we know people in the Astronomical Union also, you know, some of us.
Yes, but I'm not the only discoverer.
No.
So my thesis advisor, Mike Brown, and also our collaborator, Dave Rabinowitz, helped on this project. So we're all discoverers, and so we all have to agree, and so you have to get 3 people to agree on the same thing. And we're all picky people, so we're working on it. We've had some chats about it, but we don't have a name that we like.
You've been discussing that for 1.5 years. Wait, it was in 2007, so it's been 10 years discussing.
But we don't discuss for 10 years because we know nothing about it in the first 3 years.
I see.
So we've only been discussing naming it in the past few. And then I've also moved countries and continents. And so, I've been a bit busy. I moved to East Asia and then I moved to Hawaii. So I've been a bit busy in the last few years too. So I'm trying to fit it in.
So
I've been chatting about it, but we're still working on it. So I'm hoping we'll come up with a name that we can agree on suits the object, and also, I would like in some way to make sure, the public can be involved in some way, whether that's announcing the name we suggested when we submit it or other things. But yeah, we're working on it. It's a bit tricky, but if you do have some suggestions, you can always let me know.
Oh, I'm sure we can find something. The problem for us will be that we'll have to change all our signs now, where it says only 2007 or 10. We have to rewrite them, but I think we can stand doing that.
I'm sure you'd be happy to do it.
Tell us a little bit about yourself, where you are, and what you're doing right now.
Well, I'm currently on the Big Island of Hawaii, so we're about 12 hours difference in time zone. I work for Gemini Observatory, so we're 2 large telescopes, 8-meter class telescopes, and we're called Gemini because they're twin telescopes. So there's one in Chile in Cerro Patron to view the southern sky, and then we have the other 8-meter telescope on Mauna Kea. on the Big Island of Hawaii. So I help support Gemini operations, and so sometimes making the night plans, because we help astronomers get their data by taking it for them, so that if it's cloudy one night, we take programs that can take clouds, and if it's clear, we'll make sure we do the programs that really need to have good weather. And so I help support the instruments. I also get to do some research and help support getting other people data.
You mentioned to me earlier that this is totally remotely controllable. What is the altitude of this Gemini telescope?
Well, Mauna Kea is 14,000 feet, so I forget the conversion to meters because it's a nice round number in feet. But it's at the level of where you could feel the effects from the altitude and altitude sickness. So, it is nice to be a little bit further down. So we at Gemini is the first 8-centimeter telescope of all the big class telescopes to be fully remote. So we don't have anyone in our domes at night. We're completely controlling the telescope from sea level.
But you have been at the summit just to check it out.
I've been at the summit many times to observe on other telescopes, and also to go up to observe in Gemini and to do other things during the day with the instruments. And we still do go up, so if we have any visitor instruments or things that we'll be adding to the telescope, for specific nights, we will have night crews up there. But we can, control everything from remotely.
Tell me about the Gemini. Is it also, it's using adaptive optics, I can imagine, by now?
It's one of the pioneers, actually, of adaptive optics, and so it was one of the first. It was one of the first 8-centimeter telescopes to get a laser adaptive optic system and a natural gas adaptive optic. So basically, using either a star or using a light from a laser, illuminating a patch of the sodium layer in the atmosphere to watch how the atmosphere is sort of moving around, to then use deformable mirrors to match that to take out that effect. And so basically, you get a cleaner picture.
That is an amazing technology, I would think. That's been developed during the last 10-15 years. Did you use that when discovering the dwarf planet?
No.
No, wait. I'm off the target. That was another telescope, yes, obviously. We didn't use adaptive optics. I wasn't involved in follow-up, so I was more interested in population statistics, and then went off and graduated, and then was working on other things. So I was working on exoplanets, and so other people have started to try to follow up in 2007 or 10. So using Magellan, which is a 6-meter telescope in Chile, my thesis advisor, Mike Brown, killed Pluto, and his collaborators were able to look and see if what was sort of potentially on the surface for this object. And so they think they see hints of methane ice, which is similar to what we see on Pluto. And it's supposed to be reddish in color somehow.
It's very red. It's one of the reddest objects in the solar system, is my understanding.
So,
and that's organic. We call it tholins, but it's really organic gunk. So when you hit methane and you keep having the sun irradiate it, it breaks them down into higher order hydrocarbons. So things that go from ethane, which you might have heard of, or basically any kind of organic gunk. And so we've sort of lumped it all into one term called tholins, and they tend to be very, very red when they make these in the lab.
Well, thank you. Do we have any possible questions from the audience? I give you one chance. I think they are extremely impressed by the fact that you went up this early, and the fact that you were so kind enough to actually convey all this information. And you have a crowd of very, very grateful people who will now give you a very big hand. Thank you. Thank you very much, Meg.
Thanks.
See you. Bye-bye. Ja, där ser ni den. Det elektroniska funkar i alla fall. Ja. Det var väl kul, jättekul faktiskt. Vi kommer att överträffa det här lite senare. Nej, det ska jag inte säga.